Hello class, in this lesson we're going to look at where lines meet regions. So as a vocabulary warm-up, what's the difference between a rectangle and a rectangular region? So there are similar terms, but there is a difference. It's similar for triangle and triangular region. Well, the rectangle is just the segments that make up the sides of the region. The region is if you take that boundary and include the interior as well. So there's a difference there. So what happens if we draw a line with a slope of 2 that goes through the origin? Will it go through our region? So here's the origin, up 2 over 1, up to the right 1. And yes, it goes through it twice. And it looks like it hits this lattice point right here, the point 1, 2. And we can also double check that. And it looks like it hits right in between 3 and 4 over here. So hopefully it's 3.5, and we can double check that with some algebra. So how can we verify these? Well, here we have the line. This segment's containing the line y equals 2. So if we plug in 2 for y, we can solve that, and we see that we have the point 1, 2. Now we're going to do the same thing up here. We plug in 7 for y, for that horizontal, and we end up with 3.5. So yes, those are the 2 points. Similar idea here, but now our line has a slope of 1/2. Is it going to go through that region if it's going through the origin? So now it's up 1 to the right 2, and yes, it passes twice, and it hits these points very nicely. We can also verify that with some quick math work. So those points are the points 4, 2 and 14, 7. What if the slope is 1/3? So it's going through the origin, a slope of 1/3, what happens here? Well, it's still going through it twice, but now this point over here, where it's exiting the region, that's hitting this vertical side. So we have to be careful. Instead of substituting for y, now we're going to substitute for x. This is vertical, so x equals 15. So we can double check to make sure our points are exact. And so over here we get the 0.62, and over here we plug in for x, 15 for x, and we get y equals 5. So those are the correct points. What's up with this line? What's happening? So it's going through the origin and this corner. Does it go through the interior of the rectangle, of the rectangular region? Does it go through the boundary of the rectangular region, or does it go through both? So what's happening with this point, or with this line at this point? Well, it's hitting it just so it's hitting the vertex here. So it's not actually going to hit any of the points on the interior. So it's just passing through the boundary. So now we want to see, for which slopes would our line that goes through the origin intersect the region? So we can see over here, that this line is not going through the region. But once we hit this slope, which is that up 7 to the right 1, so slope of 7, it hits the region. And for all of the slopes up to, or down to, because they're getting smaller, down to this slope, it's also passing through the region. So the slope will be up to the right 15, so 2/15. So any slope that's equal to these two numbers or between them is going to pass through the region. So which slopes would not intersect that region? Well, if we take the opposite of this interval, that would mean that we have a slope that is either bigger than 7 or less than 2/15. Right? So any of the lines down here or lines up here, right? And what if we shifted this? What if we went up to the 0.01? What values for the slope would it go through the region? Well, similar to what we just did, we just have to shift our previous answers. Right? The graph moved up 1 unit. So does that change the slope? The rise is decreasing by 1. So instead of going up 7 to the right 1, we're going up 6 into the right 1. So similar idea for the 2/15, that changes to 1/15. So this would be our new range of slopes. In this example, we have this triangle. The vertices are these 3 points. We have the horizontal line y equals 2. So here's that line. We want to know, where does it intersect the triangle? What are those points? Well, how many times does it intersect the boundary of the triangular region? It's twice, right? And is it easy to figure out what both points are? No, one of the points is not a lattice point. So this one's kind of tricky to figure out what the coordinates are. But this one's easy, right? That's just 1, 2, 3, 4 to the right, 2 up, so the point 4, 2. So for the other ones, we got to do some algebra. So we can figure out the equation of each line here. And you should get these 3 equations. And so to figure out what this point is, I want to figure out with the equation y equals 3x, what happens when y equals 2, find the x coordinate. So we plug that in, and we get 2/3. So 4, 2 was our easy point, the lattice point, but the other point is 2/3 2. And we want to know how long is the segment. So we can use this distance formula here, same as Pythagorean theorem. But in this case, it actually simplifies because the y's are the same. They're both, it cancels out to 0. So really, we just have to do simple subtraction. So yes, it is distance formula, but when it's vertical or horizontal, all you have to do is subtract to find the distance. So it's 3 1/3. All right, what about this line? Where does this intersect the triangle here? Well, let's write that in slope-intercept form. I don't know, where does it hit the boundary? So if we graph this line, this is what we end up with. And so it's hitting it twice. We've got to do some algebra here to figure out what those coordinates are. So we're going to set what we have over here equal to this expression, because they're both equal to y, to figure out what this point is right here. And we do that, and we end up with the point 2.5, 1.25. We're going to do the same thing. We're going to use this expression, but now we're going to set it equal to this one up here to figure out the coordinates of this point. And we end up with 25/7, comma 20/7. So how do we find the length of the segment? Use Pythagorean theorem's fine, same as distance formula. I'm going to use distance formula here. We're going to round that answer. Going to round it to the nearest tenth. So distance formula just says you subtract your x values and square them, and then subtract your y values and square them, add those two together, and take the square root. Right? Because this is really Pythagorean theorem. This is how long is one of the legs, how long is the other leg, and then just follow the steps. So we crunch those numbers, and we get the square root of 3.730, etc. Plug them in the calculator, round to the nearest tenth, and we get about 1.9 units. We have a robot over here at position 1, 3 that's going vertically downward to the x-axis at this speed. When will it hit the lower boundary? So we got to figure out where the coordinates of this point, and then use what we know about distance and speed to figure out how much time it will take. Well, we already saw before that this is just the line y equals 1/2 x. So when x is 1, the y value must be 1/2, right? Plug in 1 times 1/2 is 1/2. So the length of this is just 3 minus 0.5, which is 2.5. We know that time is just distance divided by speed. So we end up with 12.5 seconds. And in this exercise, we have this rectangular region. First, we want to draw the lines that pass through the origin and through each of the vertices here. So try that, and you want to answer, it says each of them, do each of the lines cross multiple points in the region? Explain. So try that, and I'll show you my solution. So here are my 4 lines, and we can see that 2 of them pass through the region twice, and the other 2 over here only pass through the region once. This is the boundary. So there are many answers to this one. What's the equation of a line that does not intersect this rectangular region at all? So lots of correct answers here. One example is x equals -2. And that would be this vertical line over here. Okay. So now we have another robot example. So he's starting at point D, he's moving in a straight line with slope m equals 1. It hits the boundary, and then he moves himself so that now he's moving in a straight line with a slope of -1/2. So what is the final point of intersection that he makes with the boundary? So think about that problem. Maybe try drawing on some graph paper, do some algebra work. I'll show you my solution. So if we graph this, and we use what we know to figure out the equation of the lines, this segment is contained in the line y equals x plus 2. And if we either follow the graph or plug in the numbers, we see that it's going to hit this boundary at the point 2,4. And so using this point in the slope of negative 1/2, we can figure out that the equation of the line that contains this segment is y equals negative 1/2 x plus 5. So this segment intersects this boundary over here. And the equation of the line that contains this segment is x equals 4. So you plug in 4 for x, and we get the point 4, 3. Could have also gotten that by graphing it and looking at where it hits this nice lattice point. So another way to do it. So about how long is the entire distance of this robot's path? So you can use distance formula. This worked out nicely if you did Pythagorean theorem by just looking at the lengths of the triangle sides. But we have two different hypotenuses that we're going to add together. So there's two big steps here. We're adding these two distances together to figure out the total distance of the path. And we get about 6.5 units. So length of this hypotenuse is square root of 18. This one is square root of 5. You don't have to simplify any of the radicals here because we're just going to approximate distance by rounding. So you don't have to worry about that step. So in this lesson, we saw that when we have lines intersecting a region that aren't necessarily vertical or horizontal, it takes a little bit more work to figure out the answers because you got to figure out the equation of the line, do some substitution. Whereas when it's vertical and horizontal, it's usually pretty straightforward. So we learned how to determine where lines meet regions in this lesson. So thank you for watching this video.